Architecting applications and storyboard. As Jenny mentioned, my name is Toma Fletcher. I'm the VP of R&D here at Crank Software, and we're going to work through in the next hour the process of building up an application and in the storyboard development environment. And when we say application, in the past, as Jenny mentioned, we've done a lot of work where we talk solely about the UI mechanics, bringing in content from a design environment and getting it all plumbed together so that you've got a user interface that can be out prototyped, trialed, and pushed out to clients, ready for integration with the back end. But we've been a little light on discussing the topic of back end integration, mainly because we have a very comprehensive solution for it. But we tend to see that every product has a slightly different approach to what they want to do. So that's what we're going to be talking about today. I'm going to do a quick, kind of highlight of where we're at in terms of the state of the industry. For those of you who don't know about Storyboard, we're going to talk about that really briefly in its design model. Then we're going to go right into the nuts and bolts of the presentation, which is going to be talking about event-driven communication. And as we've done in the past with our more UI-oriented presentations, we are going to do a demo. We are, in the next hour, going to plumb up an application and connect it to a back end and see what the communication patterns look like. And as we do that, we're going to be understanding some of the meanings that we've been putting to words so that we can actually apply that within a storyboard development environment. So this is not a generic presentation. This is certainly lots of generic principles that we've got to pull out of here, but it is all working with Storyboard. So Crank Software, for those of you who aren't familiar, we've been around for 10 years. This year, celebrating our 10-year anniversary. Storyboard Suite is our primary product, the main focus of the company. We're an embedded UI company, and our goal is to help teams deliver rich animated user interfaces in resource-constrained environments, and that's what the Storyboard Suite product is all about. When we look at what's motivating us, right, to build the company, to build the Storyboard product, and to talk about the architecture of embedded UIs, it's really being motivated by a change in terms of what's going on with our industry today. Product development is shifting such that from a user interface perspective, we're moving away from sort of as many hard buttons and knobs and dials, and shifting towards a more flexible software-oriented approach where we're putting display panels on things. And this has been something which has been happening in the medical and automotive industries for quite some time, the shift to more software-oriented, display-oriented presentation and interfaces. But what we're seeing in the last little while is that some of our customers in the white goods area, kind of home appliances, thermostats, are also coming on board with this now. The flexibility that a display interface offers you in terms of what you can engage with your customers is very broad, but it requires a bit more diligence. The software architecture involved moves around from simply dealing with hard-wired I/O, potentially analog inputs, to more of a software configuration issue and fitting the UI software component into the context of the rest of your application. And that's where we've seen some sort of architectural challenges come up. In general, when we talk about the challenges that we see with embedded UI development, it's really around the fact that it's a complicated development process. Usually, we're talking about teams that are trying to build user interfaces using C or C++ libraries, and they're trying to do this in a manner where they're able to leverage the graphic design capabilities of their team members, but still, sort of sticking with the traditional method of a source code-based UI development process. And frankly, it's a very time-consuming process, right? Every time you have to change something, going through a compilation cycle. And for many designers that are coming from a web-based world, it's an unappealing workflow. And the notion of having a specialized tool chain, a compiler, something that you need to engage with differently from your desktop to an embedded target, even the fact that there is an embedded target and it's got a special serial connection perhaps, it's something that's relatively foreign. So if we look at the type of individuals that we're trying to engage, we're running the gamut from graphic designers, prototyping teams that are coming up with creative user interfaces. They're trying to convey those user interfaces to the rest of the product development team. That product development team is trying to get their head wrapped around how they're going to implement it. They have dozens of other concerns. When you're putting together a hardware-based product, you've got hardware selections. What chips am I going to run on? Operating system selections. What operating systems are going to suit the needs of the product that I'm building? And then application stacks that sit on top of that. And the graphics framework is one of those components. So typically we say our traditional development process is this slow to show approach, where because of the compilation, because of the complications, and because this large dependency chain builds up before you can actually see what your user interface would look like on your potential product target hardware, it's just a long cycle. It takes a very long time. So our approach with Storyboard is to adjust that, and part of the adjustment that comes in is we remove compiling. We look at giving you a different model for your UI development, one that can accelerate the product development, but at the same time not compromise on features and functionality. So the idea here is that we're platform agnostic. We're platform agnostic both from the design perspective in terms of what you're working with. You're working at a desktop environment for your UI design. You're doing this on any desktop platform that you like, whether it's Mac or Linux or Windows. And then when you take the content that comes out of our design tool, we're generating a model. So we're not involving complicated cross-compilation tool chains. We're not dealing with something that is really foreign for high-level users who aren't necessarily programmers and used to that type of workflow. The other piece that comes out of this is because we're designing to a model specification, right? The Storyboard applications that you're building tend to be very pattern-based, right? So we do enforce this model view controller or MVC pattern. If you're not familiar with MVC, it's a very popular, common design pattern that's often used with user interfaces. You may have also heard of MVVC or MVP. They're all flavors on the same theme, where you have a data model that is representing your system. You have a display presentation, which is the view, and then you've got components that connect those pieces, which are the controllers, the presentation controllers, or the view models, right? So these are ideas to keep things that are, we'll call it fickle, UI changes, independent from the model. And there's nothing that Storyboard does that is particularly different from an MVC configuration. But what we do differently from other frameworks is that we really strongly enforce these best practices by not encouraging you to start putting core system logic inside the UI. And the way we do that is through our event-driven communication model. And this is to isolate the user interface from the rest of the model. What we like to do here is, we develop a UI, and we develop a UI in a context that is completely independent from the target environment that it will probably ultimately run in, right? So you're developing in your desktop environment, you're leveraging all of your graphic design tools and sort of the comfort level of the desktop environment, and then you're able to relocate that UI design down to the embedded target platform where you're going to join it into your core model. Okay? So this is really sort of one of the key distinctions of Storyboard's approach is this enforced UI data model separation. And the way we do that is by strongly enforcing event-driven communications. When we separate the user interface from the system model, or as you see it in this slide, right, our back-end logic, what you're doing is you're really parallelizing two components of your embedded product development. You're taking the user interface, which is a growing concern in terms of the amount of effort that's involved in fulfilling a rich presentation, and you're taking the system logic, which is all of the I/O, all of the hardware interaction, all of the state of the product that you're working with, and you're allowing them to progress in parallel. So that long dependency chain that I was talking about previously, that was one of kind of the barriers for UI development on embedded systems, where I need to know the hardware that I'm running on, I need to know the operating system, I need to know sort of the graphics technology or framework that I'm running on. Storyboard alleviates that dependency, allows you to start building your user interface right away in a desktop environment, all at the same time that your core system team, will say, is able to work on engineering choices around hardware, around the operating system, around technologies that are relevant for the core product deployment. The way we achieve this is a coupling based on events. So this diagram here, you can see we have a technology we call Storyboard I/O, and Storyboard I/O it's a transport technology that allows events to flow from one side to another, very much like a pipe or a message queue. So for clients of the user interface presents a data channel, and any number of clients can communicate to that data channel by sending events to the user interface. How that channel is realized, it's platform agnostic. It's an API that has bindings for multiple different languages, multiple different technologies, and it allows us to really pull apart the model and the user interface and achieve that parallel development. Right? So we're big fans here at Crank of actually showing you, showing you the techniques that we're talking about here. So when we talk about being able to separate out our model from the core UI and the benefits of that, what we'd really like to do is we'd like to develop something together with you. So we racked our brains and we thought, well, what would be some sort of a common experience that we can put together, relatively short time frame, and do it in an hour that would be something that kind of everybody could rally around. The first thought, of course, was something around beer, but that wasn't going to work because you don't have generally beer dispensing machines. So our second thought was coffee. We'll come up with our Crank coffee machine, and so our UI designer here put together a rapid, kind of a rapid view of what such a coffee machine might look like. We're looking and modeling it after, say, a Keurig style or an espresso style machine where you've got a selection of volume in terms of your cup size. Then you have a pod that you would insert into this coffee machine, and then it would go forth and it would brew its content. Right. So visually, these are the kind of the components of the application that we would probably be designing here. The first thing we do when we start talking about how we're going to architect a system or how we're going to build a UI around a system is we're going to talk about task communication, right? So this is one of our key tenets, is we keep the model separate from the user interface, and we keep that isolation by using Storyboard I/O communication channels to exchange events and data. So we're going to start on the right-hand side here and think about the model. So what does our coffee machine actually do? What are the core competencies of the coffee machine, and what kind of interactions is it going to have? Now, it may be doing a lot of other things, but I'm going to only be kind of concerning myself with those model elements that are relevant for our user interface. So of course, we can't make coffee if we don't have one of these brewing pods. So we need some sort of a notion of whether or not there's a brewing pod that's being inserted, and we're assuming that the hardware has the capability of detecting that. Certainly, we can't make coffee if there's no water present, right? We need to be able to boil the water, and we need to also know if we're going to be fulfilling and asking a customer for the size of their coffee. We believe that if that's a feature, that we should be able to identify how much water is available in the reservoir. And then finally, once we select to brew, the progress of that brewing, right? Is it taking a long time? Is it taking a little bit of time? We know how much water we have in the reservoir, and we know how much water we're going to inject, so presumably we can derive a brewing state out of that. So those are the three kind of pieces of model information, or three pieces of information that we're expecting our model to look after. And that is going to be communicated to our user interface. So the way our user interface is going to reflect that in our current UI, and again, the model doesn't, is completely independent here. It doesn't care about how this presentation is being achieved. Is we're going to look at, the brew being enabled, whether or not the user has made a cup size selection, and then, of course, once we start brewing, we'd like to be able to provide some feedback, whether it's in the way of incremental feedback or simply a statement that your brewing is complete. So the feedback that's going from the user interface to the model is really going to be probably a singular command indicating once we've made the desired selections, this is what we would like you to do. So we can break that sort of abstract data model down a little bit to a bit of a task diagram here, where we get a little bit of a workflow interaction. And here we have really kind of four participants in our simplified model: the user interacting with a user interface, the hardware interacting with the model, and then the user and the user interface and the model having a relationship with each other, right? So we can think about how we're going to interact with our coffee machine here. The user is going to change a coffee pod. The hardware is going to detect that change has occurred. It will report that into our core model, and the pod status will be updated. The model will signify an event to the user interface, and the UI will reflect some sort of update. Now, what's important here is that the UI update is really inconsequential to the model. The model is not caring about the type of UI update that's occurring, or whether the user interface does anything with this information. It's simply a matter of making the data available so that the UI can work with it. Again, the user is going to select a coffee size in terms of their brew amount. Here, we're not taking any information about water level into consideration. The user interface is concerned about that information, but at this point in time, it's not passing that information through to the model, because the model doesn't need to know about the coffee size until that information is required for some operation, right? So this is a good example of where we're isolating pieces of information and levels of interaction to just one component. In a traditional sort of UI environment, what we might have done is we might have actually made a coffee selection in the user interface, and then that would have gone through all the way to some underlying model, because that was simply the way that the code was organized. It was all there. If I have an I/O that's a hardware element and I'm making a selection, well, now I'm on the other side. I'm in the hardware selection side. So of course that size information has to be recorded somewhere. It's going to be in the model. In our world, where we've got a little bit more flexibility, we don't have to burden the model with some of these ancillary pieces of information. Then finally, once we've recorded a coffee size, then the user would like to select to start some sort of a brewing process. Now, keeping in mind that this is a simplified task flow just to kind of keep us on track, we're saying, essentially we've had to establish a size, so we're going to start the brew with a size, and that's going to be our communication from the UI to the model, that we would like to start the brewing. The model will interact with the hardware. The hardware will either decide that there is, brewing that can occur, or maybe there's some sort of a brewing error, and then the model will iterate over the status of the brewing, reporting it back through to the UI, where the UI is free to do whatever it wants from that presentation perspective. At the point where we're done, we would finish our brewing. Now there's an opportunity here for us to do additional UI updates, or maybe that our status has got enough payload information that we don't need to do it. But what's important here is that there's different levels of interaction, right? Not everything that the user engages with at the user interface level has to be reported all the way through the model. Things that are purely user interface concerns can be restricted to simply that environment. Similarly, the model is responsible for maintaining state information about the system. Not UI state, not necessarily state of the visual representation of the data, but the state information related to the system. So if we think about this in the context of what we're talking about here, is there a pod inserted or not? Am I brewing or am I not? Right? What is the progress of my brewing? These are the things that your state model is interested in, and you'll notice that for the most part they are all headless. They are not. They can be represented by some form of visual presentation, but they are core data, right? And that's what's really kind of the key separation when you're putting together these systems, is that you want to isolate the model to contain state information and the user interface to contain state information about the user interface or about the kind of the workflows that are going on, but they don't necessarily always need to be entirely combined. So I'm going to just kind of take a quick moment here to talk just briefly about open versus closed loop communication. And this is open versus closed loop communication in the context of a user interface. In general, when we're building up user interfaces, we're looking for them to be agile, we're looking for them to be responsive. We don't want to be causing the user to sit there and not be able to engage with the product. And what that means is that your UI can't be churning. Your UI can't be spending cycles doing expensive processing and computations, because if it's doing that, then it's sacrificing the interaction with the user, right? So the way we do that to kind of solve that in the storyboard context is that we make sure that we're using our events and data payloads to move all these expensive operations to either the model or some off-process core system logic, right? So we can use Storyboard.io to do that. And when we do that, if you think about what a UI workflow generally entails, is that users are making a series of selections. Those selections are then being stored locally within the UI, as in our coffee cup selection, or they're being conveyed through to kind of a back end, a model where there is work to be done. When you're communicating within the UI, you're going to remain responsive because you're really just doing data bookkeeping. So you essentially are achieving your kind of open loop process because you're continually allowing the user to move the UI along. As soon as you start having a dependency in terms of a requirement for confirmation or validation, then your UI is now talking to your backend. The conversation that you should be having, the events and the data that should be flowing back and forth, they should be just that. They should be events conveying information about not the UI presentation state, but the data state, right? So for example, a good example of our closed loop here would be where we send an information to say the user has chosen a cup size and we would like to start brewing, so we are going to send a message saying we would like to start brewing, and we are expecting a response. Now, the way we craft our UI is that we expect a response in the way, or in the form of some sort of progress or notification, right? It allows us not to block the UI in terms of stop its responsiveness, but we can come up with a visual affordance that allows us to softly block the user interface, right? And you see this, for example, at startup, where you put up a splash screen or a boot screen to, tell the user that you're actively doing something, but you can't proceed before you get to the next step. This would be the same situation with our brewing. We can't start brewing another cup of coffee until the first cup is done. So the brew notification is a closed loop system, but it's not necessarily a blocking user interface. Which brings us to our cranked coffee machine event definitions. So having carved out the general design, the interaction model that we wanted to have, we can now start to have our design team and the engineering team come together. And this is sort of the common gathering point when we talk about these, the construction of these user interfaces, because you want to empower your design team with all of the information that they will be able to use and manipulate in the course of building the user interface. At the same time, you don't want them to create functionality that doesn't exist. We have a kind of a historical story of a product team that went and created a very low-powered device, and it had a very nice clock on it. And that clock was simply not something that the system could actually engage with. It simply couldn't maintain the clock for power management reasons, but also from a connectivity point of view. It simply was a feature that was built into the UI that simply could not exist from an engineering point of view. So it's important that you come together as an engineering and design team to come up with these event definitions, to discuss the motivations behind what the information is and why you need it. It's important to look at the granularity of the events, right? You can use the UI as a guide in terms of, we believe that the UI might look like this, so it would be convenient to group data together in that fashion. But that's simply a guideline. UIs are very fickle, they change frequently, so you never want to base your data communication model in terms of the data that you're sharing between model and user interface solely on a particular presentation, because that presentation will change over time. It's much better to look at the core functionality of the system. What data changes frequently? What data is relevant and should be grouped together? Those are the things that you want to consider when you're building up your event definitions. And the event definitions are really an application programming interface. If you were doing this entirely within the sort of one language development environment, these would probably constitute function calls with parameters. They would look very similar. So let's talk about what we have, what we've crafted for our coffee machine. So I'm going to start again on the model side, because we know what the model is tracking, at least as far as the user interface relevant pieces of data. We have a water level, so we would like to receive an event when the water level has changed. The event should contain a notion of how much water is available, and so we'll nominally call that out as the capacity, and the units of that should be some sort of an integer unit. And when you're dealing with data elements like this, you really want to be clear to call out what the units are, and the units should be consistent. You shouldn't be looking at an interface or an API where the units change. Despite the fact that you may have a product where it's being internationalized or it's being themed so that I can make some user-level decisions about, am I showing content in ounces or am I showing content in milliliters, right? Am I metric or am I imperial? That is a presentation level concern. Your core API should always be dealing with data in a cohesive set of units. And you shouldn't be building user presentation functionality into your API for data transfer, right? It's error prone. It renders the stateless nature of your UI problematic. And frankly, it means that you're spreading work between now your model and your UI. If the user preference changes in the UI, in terms of perhaps we allow a mixed mode, imperial and metric, and then we allow some parts to be imperial and other parts to be metric, now you've got to maintain that type of granularity all throughout your core model, where it would be better to maintain your core model in a singular set of units, always transfer that to the UI, and the UI becomes responsible for transforming that core data to a presentation. And the presentation would not just be the visual presentation, but it would be labels and unit conversion at the same time. So the next event we have here is whether or not there's a coffee pod that is present. It's something we would like to have as a functionality in our machine. So we'll pull that out, and it's an enabled and or disabled state. Now in this case, it's really a Boolean value, so we could use a much smaller integer value for this, simply calling out 1 if it's present or 0 if it's absent. So sizing wise, we don't need quite the same magnitude. When it comes to progress, we would like to be able to report the progress to the user. Now, we don't know how the UI would like to present that information, so what's a choice here that we could make? We could present progress in terms of a general percentage and allow the UI to represent that in whatever way it would like. That may or may not provide enough flexibility to our overall presentation. Again, we're making UI presentation level decisions when we decide that we're going to send just percentage information up. That's assuming that the type of presentation that the UI wants to make is based on percentage. It's better instead to go back and say, what is the core data associated with what it is that we're conveying here? Our brew progress is that we would have a target amount of water in this case that we want to run through our coffee, and then we have an idea of where we are in terms of how much water we have currently pushed through. So those are the two pieces of information that we want to convey, right? That is what's going to make up the brew progress event. And of course, it's always kind of always interesting that we're building up a world where the core model and the user interface are separate. If you were making direct callbacks, for example, you might be able to simply return error codes out of your callback functions if things went wrong. In this case, if the model detects that there's some sort of an error, then we should have a mechanism for communicating that. Now, this one is a little bit different. Previously, all of our events contained integer data values. In this case, we're mixing integer data values along with perhaps some sort of a diagnostic message. It's a questionable action to do, because if you have a translatable product, what does that message mean? Where is that message coming from? What is the origin of that message? In general, some sort of enumerated code that can be translated and generally looked up is an ideal situation. A mix of both is certainly possible as well. You can use them as diagnostic tools, translate the messages, and use them as keys, and that gives you sort of a constant fallback. It's not always 100% clear that there is just one path to follow in these scenarios. So that's the sort of the outbound event configuration that we're looking at for our coffee machine, going from the UI to the model. I want to go the other way now. I want to actually talk about the model to the UI, right? We only really have one piece of information here. This is our brew start message, right? And as I indicated, the user is going to pick a cup size. That cup size is going to be the target information, and we're going to send that along. You'll notice at the bottom of the slide here, the coffee model and the coffee UI. So using Storyboard.io, we have named communication channels as part of your API definition for the product that you're building. You want to call those out right away, right? And you want to identify them. So we spent a lot of time on this slide, but that's because this is really, when we talk about your core architecture and your design for your product, the event definitions are what's going to release the two teams, the UI development team, to go off and work in parallel at the same time that the core, the core product development team, we'll call it the UI headless team or the model team if you like, is going to be able to go off and fulfill their capabilities. Because now we've established a common API where we come together. We've got an event-driven communication, and when we couple that together with a workflow interaction, we have something which we can go and build a product around, right? And so that's what we're going to do right now, right? This is where we look at how we accelerate this development process. And we're going to leave the slides at this point, and we're going to jump into Storyboard itself. We're going to plumb up the user interface for this coffee machine using the events that we've defined. We're going to see how that looks. And I'm going to be using Storyboard 5.2. And in Storyboard 5.2, we started to enhance it with some additional features that allow you to more easily build these type of simulations. Because with Storyboard.io, it's a communication channel. It's not about the endpoints. It's about the fact that you're sending events out a communication channel, and there can be lots of different endpoints implemented for that communication channel. So what that really means is we're going to be building a user interface on our desktop. We can communicate that user interface's information and selection to something which is our model proxy. The model proxy is not a real implementation, it's a simulation. It could be implemented using some command line scripts, it could be implemented using Lua, it could be implemented in C or C++. But the important thing is that you don't need to have all the functionality of the model available to start interacting with the user interface. Similarly, we can turn that around, and we can say the core team can build their model without the UI team having any progress made on their general presentation, and they can do that because, again, we have an event communication specification. So let me just jump out of here. So the model that we're building was bootstrapped based on Photoshop content. Part of what we're introducing in Storyboard 5.2 is Photoshop artboard support. So we were able to take all of the screens of our application and immediately import them into Storyboard. That's a story for another day, unfortunately. We don't have time today to talk all the way through that. Now what I want to do is I have this application inside of Storyboard, and I have my event list. So I've gone through and I've already created the screens, and what I'd like to do now is start adding in the behavioral elements. So if I simulate this at this point in time, I have a visual interaction that gets me to this point. Now, there's some things you'll note about this visual interaction. The first is when I come in here and I'm selecting my sizes, yes, I've got the visual information, but I don't necessarily have any water here, and I don't know that I have a pod inserted. So I need to put those water reservoir level and pod insertion events into my UI. So our traditional mechanism for doing that is to add in an action and come in here, and we would add in a custom event. So in this case, right, for example, let me just take a look here. I have our pod status event, and I know my pod status event is using a small piece of data, and I'm basing this, what you're looking at here, I'm basing on the content that we've developed here, right? So there's no surprises. This is an API that's already been discussed and assembled, so I can start plumbing it in and I can start using this information. So I can create my pod status event here, and when I receive a pod status event in the context of a Storyboard application, then I can react to it. And in this case, I've already put in some work here. I can say I'd like to invoke my pod status callback, which will do something for my UI presentation. That workflow is something that we're enhancing with Storyboard 5.2. Storyboard 5.2, we're providing you with an alternative way to come together to do the event API definitions. And that's our event editor. So instead of going through and annotating this pod status and doing the events one at a time, I can come into here as a common rallying point for creating events. And so, for example, while I'm doing my specification in the design team meeting, we could be building up the event definition file for the project. And then I can come in here and I can choose the type of data that's associated with my water level. For example, maybe a 16-bit unsigned integer. And what do we decide? We wanted to give that some symbolic terminology here. We'll give that capacity, right? And then we have one final event that we'd like to add in, and that's our brew progress. These are all the incoming events that the UI needs to respond to. These are not the outgoing events. And what do we say? 16-bit unsigned integer. And I can make this my target. And then we'll also have the current value. So now that I have these event definitions in place, I can come in and finish plumbing them in. Those event definitions are all going to be here. I have my brew progress that I can hook up to my brew progress. And I can add in my last event here, which is my water level. And we're using Lua as our glue logic to take and transform the event data into a UI presentation. So I'm now at the point where I can re-simulate my application. So this is, again, all running on my desktop platform. And I can come in here and I can make some selections. Now, this is not the steady state that I expect it to be in, right? I expect that when I run my application, if I come up, my system is not yet initialized. I don't want to allow the user to actually engage with the UI in an unknown state, right? So one of the key tenets of doing this UI development is that you always want to make sure that you are you're giving yourself an initial state which is reflective of the most safe behavior, right? The type of behavior where the user cannot progress because you do not have the information yet from the back end. So what I'm going to do is I'm going to disable my interaction points, right, with the visual presentation that I'm looking for. And now, when I run my application, I can start my coffee machine, and I am at the point where I cannot interact with it, I cannot progress because I have not received the events from the back end. I have not received the water level, the pod status, the brew progress. Now, normally this would be the point where you're just stuck. This is where we can leverage the functionality of Storyboard's simulation capabilities. And the Storyboard I/O communication channels, because they're agnostic, allow us to use command line utilities to generate our own events. So I can generate into my coffee UI a water level event and simulate what it would look like, for example, simulate, I forgot my qualifier here, simulate what it would look like, no, that's because I'm speaking and typing at the same time. Simulate what it would look like if I were changing, for example, the water level capacity. Right? And now I can proceed and I can move to the next step. And for example, my brew is now disabled. I can go back and I can say, well, no, actually what I wanted was a large or small. And until I turn on our brew enablement, so our pod status event. And you'll notice here, if you're familiar with Storyboard syntax, what I'm putting in here are qualifiers that describe the actual data that's being sent. Enabled. Let me make sure I get that right. And now once I do this, I can start my brewing process. And again, at this stage, I'd be brewing on the hardware, and I would expect to be communicating information up to my client. I don't necessarily have this client here right now, so what I can do is we also have the ability to use the Lua scripting language to its full capacity to generate these events. So I can do something that's a little bit more sophisticated. And if I take a look at what we did over here, all of this is impacted or is contained within our simulation files here. Then I have a brew start simulation, and what the brew start simulation will do is it will actually wait for an event and then simulate our brew data. And the brew data simulation is exactly our brew progress event that we've done. So let's do that. And if this seems like a lot of typing, normally what you'd be doing is you'd wrap this all up into your own, I believe that was what we called it, brew start. Right? And now I've got my UI simulating, right? Responding to events and moving through. So that's great. That's a very quick way to, build the app, check the responsiveness, check the behavior, right? I can simulate the content. We didn't get into the details of what the simulation looks like, but it's all being driven by events. All of these clients, IOGen, iReceive, DSP Lua, they're all doing the same thing. They're generating Storyboard IO event information. Now, I don't want to leave the C developers behind, because what they were doing is while we were working on this UI, they were working on their model. They were working on the model side of things. And remember, the thing I said that we're trying to do with Storyboard and the architecture is we're trying to get the UI development moving in parallel with the core model development. So they're working, the core model team is working with the same event definitions, right? For example, the water level and the pod status here. And I'm going to correct this mistake I noticed here, the pod status event. And they're doing this, and they're building it up, and they're working, but perhaps they don't have the full UI available to them. Oops, let me come back to that. They don't have the full UI available to them, so I can still, right, I can run my coffee model here. But if I don't have someone to talk to, I don't have a UI to engage with, how can I actually test and validate? Maybe the UI team's not ready. Well, again, I can use the fact that the Storyboard IO channels create a completely decoupled development environment. So I can actually pretend, I can run our IO receive utility and pretend like I'm the UI. So I can say I am the coffee UI, create a coffee UI channel, and now I'm waiting here, and now I can test the C code that I've written, and the C code that I've written is relatively straightforward. Connects to a coffee channel, and then it starts sending events. It sends the water level event, the pod status event, it pretends to pour some water in, and then it inserts a pod, and then we don't do anything with the brew progress after this, right? So I can, as a C developer working on the model, I can test this by using our IO receive. My UI team, I don't know what they're doing, right? They're off doing their thing, but I can make sure that the data that I'm generating is aligned with the specification, right? And that's an important part of being able to test, validate, and work in parallel, right? So we can see here. So now what happens is when I bring these two things together, if I just sort of terminate this application, I can bring these two worlds together, right? I can say I'd like to run my application here. Now, because I'm running my simulation environment in a world where I can actually do the compilation and I'm building off the desktop, I can now run this coffee model, right, my C API that I validated that I'm generating the right information. I'm generating a water level statement, pod status, so I can come in here and I can start my coffee machine and I don't have any of my cup sizes selected. I can start the coffee model, and what the coffee model is going to do is it's going to pretend like it has all the state information ready to go. We'll wait for a few seconds here, and then we'll start pouring our water in, and you can see here my UI is responding. It's behaving the way I expect. At this point, I can now start engaging. Now, of course, we haven't generated our brew, our pod insertion yet, so now it's available, and I can go, and now I'm still at the point where, well, the core team haven't finished the model to be able to handle the brew status information, but I can still work with the simulator, and I can make sure that my UI workflow is complete, so I can start the simulator here, and I can generate those events. So again, I'm taking advantage of the fact that I can do this from lots of different types of environments, right? I can pull it from one side or the other, and when I finish the coffee, then I'm ready to go, right? The great thing here is, if I come back in, all this state information, I've already got a water reservoir full of water. We haven't actually decimated it. I can come in here, I can say I have a small, and now what I'm doing is I'm actually brewing with the old pod because we never got a pod removed message. So this would be like, you know, if you're reusing your K-cups, this would be the type of workflow that you would get, right? And we can actually see how that would look, right? Do the same sort of thing. So there's a couple of things I'd like to show you. We're running a little short on time, so I'm going to just kind of accelerate through this. Coming up with Storyboard 5.2, what we're developing is we're developing a new functionality. So the simulator that I wrote in Lua or the command line utilities, those are interesting. They're nice to have, but we want to make it even easier. We don't feel that if you give us all of the information with regards to the event workflow, there's no reason why we can't leverage that information to give you an even easier simulation environment. And that's where we're headed. With Storyboard 5.2, you'll have this new Storyboard I/O view. And so we'll be able to come in here and we'll be able to say, for example, I can set my water level and I can set the capacity. Well, the value is a little out of range here, so let's make our capacity, you know, up to 1,000 liters, right? And now what I can do is I can drive this capacity and change its value, right? And I can actually see what the live interaction looks like within the UI. So I can actually see that the simulation is doing what I want. I can come in here and I can say, great, choose a medium. Oh, I haven't done my pod status yet. So let's go to my pod status. And the pod status is simply really a 0 or 1 enablement, right? So I can go and change that, enable my pod. Perfect. Now I'm brewing. And what I'm doing now is I want to monitor my brew progress. And let's fix up our target here and make our target run to 100. And maybe I don't want this as a live update just yet. So let's put it to 100. And then my current value for what I'm aiming for, I'm also going to drive it from 0 to 100. Now I can turn on my live updates. And if I start drawing my current value, I should see, oh, and then maybe my cup got a hole in it and it leaked it a little bit. But then I was able to fill it up some more, right? Again, the goal here for you as a developer is that we're building an API, we're separating the core model and the UI, we're allowing those teams to work in parallel, and we're accelerating the development process. So if I can just kind of come back into the slides, I know there's a bit of a whirlwind tour through things. I'm going to come back into the slides here just for one last thing. A quick review of what it is that we looked at and what we did this last hour. We were talking about Storyboard I/O application or Storyboard-based applications, how to design them, some of the guidelines. The idea here, you want to build the two components separately. Your core model should always be built in a way such that it doesn't need the UI to operate, right? It may need inputs, but it doesn't need inputs specifically from the UI, right? You shouldn't actually care what screen you're in, what type of presentation you're on, right? The model is looking at the data of the system, and the UI is passing information to it that is the data of the system. And you can simulate that using tools and use Storyboard I/O communication to decouple that. And that really, kind of speaks to the second piece here. Consider the user interface as a separate entity, very distinct. when with Storyboard IO, we're really working in particular in sort of these larger operating systems in separate memory protected processes. So the IPC that's going on is truly event-based communication between processes, between memory address spaces. So when you do that, you can be absolutely 100% sure that there's no leakage of data between the two pieces, right? You're not accidentally going to be inspired to invoke a callback and just reach out to code and do something that you know would violate your MVC pattern just because it's quick, it's easy, and I can do it right now, right? And that's usually what happens with a lot of frameworks where MVC is the model, but then it breaks down. When you're designing your events and you're looking at your data exchange, make sure you're exchanging data that's in the units of measurement, not of display. You'll notice our coffee machine was all in ounces, but all of our data was in milliliters. We're quite happy to share this project, and if you shoot us an email, we'll share the project with you. We have a data conversion component, which is part of the presentation layer that does that conversion. And this is important when you get into translation and internationalization concerns, right? You want to make sure that your UI is dealing with data from the systems, converting that data, and presenting it based on user preferences, and not the other way around. Not the system giving you data that's already been user preference configured. And we didn't really spend a lot of time looking at this because we were kind of running short, but one of the things about putting together our events is how you organize them, how you group them, what data should be contained in what event. That's a conversation that's very product specific. You should think about the context of use, the context of relevance, and general frequency of updates, right? Putting slowly updating data along with fast updating data, you usually want to pull those apart and separate them. For the astute observer, we went through this really, really quick. These are the events that we defined, but you'll notice that the model that we're using here is actually a cohesive model. Because of the size of this application, we have defined all of our events as distinct symbolic entities. We could actually share this entire model with the UI, for it to use, even though we're using discrete events, right? So there's always some choices that you can make, right, in terms of how data is going to be shared with the application. So I know that my moderator Jenny, my moderator Jenny's going to be after me because she's saying it's been an hour. We should get moving on, Toma. So I do like to leave some time for questions.
I've assigned a couple of questions to you there. If you could do a little speed round while we still have
I can totally do a speed round. So let me take a look at these questions. So we actually have, our questions are, this is sort of a new format for us, so let me take a quick look here. So is it possible to debug Lua scripts? Absolutely, absolutely. It is very possible to debug Lua scripts. It's a relatively simple enablement. It's a configuration option in the simulator. So if you come into our simulation here, you can say, I'd like to turn on my Lua debugger. Once you do this, and we say, let's apply it, I want to go and put a breakpoint in. Then once we do this, all of your code, well, this is the simulation code, I want the callback code, all of your code works much like anything else. So for example, I can put a breakpoint in the trough here of my size selection, and when I run my application, I come in here, my coffee start, I don't have the UI set up yet, so let me go and make some water, right? Give myself some water so I can select it. If I select this, you'll see I'm going to be asked to go back into a debug perspective, and now once I'm debugging Lua, then I'm able to do some work, right? And the debugger works much like any other language debugger, so you can go through and look at things, right? Let me just take a look and see here. What else we hear? Oh, wow. Okay, I got a few more here.
I just want to quickly say for anyone who has to drop off, I will be sending the link to the recorded webinar out in a couple of days. So if you have to drop off, that's fine. This will be available on demand.
So there's a question here asking about minimum recommended task rates for calling the Crank UI. Certainly not any minimum rates. What you can do is if you have very slow changing data and you would like it to be smoothly animated. So for example, the animation that you were seeing with our cup, right, as we fulfilled our cup here, that rate was being driven directly by the data. You can certainly intercept that and actually convert that change, that motion, from just simply a data operation to more of an animated operation where you're smoothly filling. So you're going to be moving the data up based on an animation. The animation is going to be triggered by your data updates. If you're concerned about providing too many updates to Storyboard, Storyboard also throttles the other way. That we automatically will choose the best frame rate available for you based on the data updates that are coming in. So you may be updating your data, for example, at 100 hertz, right, 100 times a second, but we actually are receiving all those data changes, but only performing visual updates at a lower rate, perhaps. Someone asked if it was possible to use Storyboard.io everywhere. Yes, absolutely. So Storyboard.io is available on every platform where the Storyboard engine runs. The implementation differs in terms of if you're using it in a memory-protected environment or a non-memory-protected environment. The implementation tends to use something which is optimized for the platform of execution. And but as a generic API, that's the way we've designed it. So I can take this C code that I developed here, and I'm compiling and running on Mac. I can take this, and you'll see we've already kind of if-deffed it for Windows for a few things like, you know, the difference in sleep functionality. But I could take this and run it on FreeRTOS, right? And I would be able to run this application on FreeRTOS without any modifications whatsoever, right? Assuming that the kind of the core functionality, such as these system calls, is available. But that's outside of Storyboard.io. That's really a C concern. Someone asked, when is 5.2 coming out? Great question. I need the simulator event thing. Well, you know, the simulator event thing still has some rough edges that we're polishing on it. It is pretty awesome. I'm not going to lie. We've been looking for something like this for a long time. We've always had this capability of generating data very easily. This makes it so easy that you're never going to not do it. Our tentative release date for 5.2 is scheduled for February, but if you're interested in being part of an early release program, certainly drop us an email at support@cranksoftware.com or sales@cranksoftware.com, and we're happy to put you on that list. We're excited about it too. There's a lot of exciting stuff coming in 5.2. All right. I showed an error with a message. Oh, one more.
One more? Okay.
Isn't that against the guidelines for translation? It is. And as I mentioned, you know, string content is always a bit contentious. You know, it is going to come down to how you are structuring your application and what you have in it. You can use strings as keys into other databases to allow you to do the localization. And in general, if you're pushing a string through from your core model, it's because your core model knows about that string. And hopefully it doesn't know about the content. It only knows about the fact that it's pushing a string. So I'm getting cutting it off, Toma. Yep. Thank you very much for coming. The samples that I showed today, we will be packaging them up and making them available if you're interested. And certainly, if you're interested in talking more about Storyboard.io, drop us an email, support@cranksoftware.com or sales@cranksoftware.com, and we can take this to be a one-on-one engagement.
Excellent. Thanks so much for your time today, Toma, and thanks everybody for your attention, and we'll give you back the rest of your day. Thanks for coming out.